Another request for Unit 2, Computational Thinking. Thinking like a computer science, not about programming, it's about problem solving. Okay, so what is abstraction? It's removing or filtering out unnecessary information and focusing on what matters to solve a problem. So exam tip: abstraction is about removing irrelevant detail, not simplifying the solution itself. It's nothing about making a simple solution. It's about just removing the unnecessary data for that problem. So only the relevant data is there, and you can solve the problem with the relevant data. For example, build a bus system. You don't need to know the driver's name, the seat color. That's irrelevant. Removing those two, we're only left with the relevant data, the stop location and the route numbers. That helps us now solve the issue. Decomposition: breaking a complex problem into smaller, more manageable sub-problems. Each small part is easier to solve. In your exam, always name the specific sub-problems when describing decomposition. So, for example, building a game, graphics, sound, control, storage, you can break it down into these subsections, and then each problem can be managed by different people, different department, etc., etc. So you might also be asked to draw a structure diagram that demonstrates this decomposition. Algorithmic thinking: developing a step-by-step set of instructions to solve the problem. If the steps work for one case, they may work for all. So there's no point rebuilding the same steps over and over again. If you build these steps correctly the first time around, you may be able to use these steps for future problems. Exam tip: algorithms must be precise, unambiguous, and produce a result in a finite number of steps. You shouldn't be doing hundreds and thousands of steps. It should be simple, clear steps to solve a problem. Context challenge: which detail would a developer abstract ignore when designing a digital bus map? So click each card. If it's red, it means it's been removed. Teal, kept relevant. So for example, bus driver, that should be removed. We don't need to know the bus driver's name. Bus location, correct. We need to keep that's relevant. Color of the seats, no. Route numbers, tire pressure, again, unnecessary. Why do we need to know the tire pressure if we're just trying to make a map, bus map? We don't need to know the tire pressure. We don't need to know the color seats or the bus driver's name. Okay, so some exam questions. Decomposition. Decomposition, abstraction are two computational thinking techniques. State the name of the computational thinking technique for the following description. Breaking a complex problem down into smaller problems. That would be called decomposition. And that was the student's answer. Correct, 1 mark. Abstraction. It's abstraction, you only keep it. So state the name of the computation for the following: hide or remove irrelevant details. The student wrote abstraction, correct. Creating a logical set of steps for solving a problem is algorithmic thinking, correct. Writing code down into steps. These are all past paper questions. State one reason why a computer science would use abstraction when developing a complex piece of software. It makes the problem easier to solve by removing all the distractions like seat colors in a bus app. Full marks. Again, makes the problem easier to solve by removing all the distractions. Simulation. Okay. A programmer is creating a car racing simulation. Explain how decomposition could be used during the design of this simulation. Breaking the racing game into smaller parts. One part could be physics of the car, another could be the track design, and another could be the high score system. So that this student has written all the different parts, that will give you full marks. So and this is all about being able to identify each type of algorithmic thinking skills and explaining how they can be used. That's that section done.